Welcome to the last but not the least session of the celebration. Again, it's been a terrific meeting, and thank you so much for keeping your stamina up. It's been exciting. Now, as you have seen so far, to achieve all that sort of IDS has achieved over the last 8 years, it has taken a village to do that. In this panel, what we're going to talk about is what IDS has been trying to do to go global in terms of online education. And clearly, to do that, it's not just village, it's feels like sort of we need a world to help with that. And some of the panelists do reflect that. So really sort of excited to have 4 amazing panelists. I won't take much more of panelists' time, but I just want to sort of quickly sort of tell you a bit about how we got to IDSS online education or IDSSX. As we launched IDSS and as Manzar remarked yesterday, one of the things that sort of we wanted to do is not just do institution building within, but also outside. And Manzar had the vision of setting up the global education program. At the same time, MIT as an institution was extremely supportive and encouraging through a variety of channels where the idea was that let's remove the physical barrier to education in terms of campus, but let's retain the quality of education in terms of the merit. And that's where the amalgamation of all sorts of amazing programs have come together. And there's a nice cheat sheet that's there. So in case any one of you is interested in taking the IDSS's online education program, you might want to go through this nice decision tree. And that will tell you which of those 4 programs that you should take. And all of these panelists are going to tell us a little bit about some of these programs and their help and experiences as we sort of build the programs and we're trying to make them successful. And with that, what I would like to do is I would like to introduce our 4 panelists. So we've got Karene Chu there. Karene is the Assistant Director of Education with MicroMasters in Statistics and Data Science. I mean, just to be honest, Karene and Suzanne and the rest of the MicroMaster team is what sort of the MicroMaster is. So they do an amazing job of sort of actually not just keeping the MicroMaster alive, but also sort of continue it to grow. So thank you, Karene. Lucia, Del Pilar, Haro, Gonzales. She has traveled a distance to be here. So first of all, thank you for being here. She has been our partner from the outside, where she's been taking the programs that we have developed as a part of this IDSSX and bringing them to their local community. And some of the participants and some of the successful folks who have finished this program are actually in the audience, and I'm sure we'll hear a little bit about them as well. We've got Milind Kopikare, who is president of Great Learning North America, and Milind and Great Learning have been amazing partner for IDSS X to sort of bring the education and content that we build within the MIT to bring to the rest of the world. And again, that's a completely non-trivial task. And thank you, Milind and Great Learning, for being an amazing partner there. And last but not the least, John Tsitsiklis. We all know John really well. And one thing, among other things, so among many other things, one thing that sort of you do want to imitate of John is how to teach. How to teach not just to you and me, but how to teach anybody in the world, and anybody in the world probability. Now that's a non-trivial task, and we're going to hear a little bit about his experience as sort of he went through that building those courses. Like I remember colleague of Milind, who's also the CEO of Great Learning, is saying that, well, after looking at the John's probability class, I thought that I think I can learn probability too. And so that was a sort of, that's not an easy compliment to have. So with that, I think I'm going to sort of invite panelists in alphabetical order of last names. With that, Karene, please.
Thank you, Devavrat, for the very nice introduction. Before I put up my slide, I want to thank Munzer and Devavrat for giving me the opportunity to be part of this vision of bringing MIT education to the world. Every day since then, whether I'm interacting with them or with the amazing course faculty or the also very amazing graduate students and postdoc, I'm learning amazing thing every day. So thank you for bringing me in. So I need to get to my slides.
Okay.
Yes, I got it. Okay. So I'm really excited about IDSSX, but while I'm excited about all of the components of IDSSX, I want to tell you about the longer term part, the portion that is more rigorous education within the IDSSX, which is the MicroMasters program in Statistics and Data Science. So what is the goal? The goal, as Devavrat has already mentioned, is to bring, is to remove the barrier of the campus, but still have MIT level of rigor education brought to the world. The MicroMasters is a professional and academic credential for online learners all over the world, and we have some representation here from Peru. And then once you have the MicroMasters credential, you can apply that for credit for master's degree at 30 or more universities, our pathway universities, and it's also a pathway. There's also a pathway into the IDSS PhD program in social and engineering systems, where the admissions is completely independent of the credential. But once you're admitted, the online credentials, the courses can be applied as credit. So how are we doing with reach? Because we said that we want to reach out to the world. So far, we have, since 4.5 years ago, we have now more than 1,000 credential holders. We have reached more than 500K unique enrolled learners. Out of them, more than 25K unique verified learners. Unique verified learners mean they have identity check and they paid and they are committed. We have issued more than 27K certificates, so each course comes with a certificate if you pass. And there are 195 countries represented and a wide range of industries represented, and also different range of level of education. From secondary school, most of them, 45% is, have a bachelor degree, and many of them, I think around 30%, also have a higher degree. So then let me tell you a bit more about what it is. We're claiming that it's MIT level, so what is it? So it is Devavrat's and Munzer's vision that, the education should include the 4 pillars of data science, is what I think they think of everyone in the world who practice data science should know. And these 4 pillars are probability, statistics, machine learning, and data analysis. So we have courses in each of these areas, and at the end of the 4 courses, there will be a final comprehensive exam. It's virtually proctored, and it's, covers all 4 courses. So what are the courses? We have probability course from Professor Tsitsiklis. It's equivalent to the course on campus, the sort of cross-listed undergrad graduate version of 6041. Professor Gonzales, 18650 from course 18, so a math course on fundamentals of statistics. Professor Barzilai and Yakula's machine learning in Python. It's equivalent to the cross-listed 6036 on campus. And then in the data analysis and an upcoming time series course, so we have 2 data analysis courses, one from Professor Duflo and Sarah Ellison. It's in econ, it's data analysis in social sciences. And more recent addition by Professor Aller and Professor Jagielka, which covers 4 different domain areas, data analysis in 4 different domain areas, along with tool sets that is commonly used. And upcoming next spring, Munster, Devavrat, and Martovich is making a time series course. So, our vision is to keep expanding the curriculum so that, the curriculum here can be accessed by the world. So I'll tell you a tiny bit about the philosophy of these online courses, because maybe when you hear online courses, you might think, oh, it's not that serious. But actually, it is quite serious. So the philosophy behind it is, well, we learn by doing. And because the learners around the world have very varied background, we need to make sure that everyone can get to the end, provided that they are willing to put in the time and effort. And so to that end, we build in a lot of scaffolding. Scaffolding is just a fancy word for saying, well, we will segment lectures into 5 to 10-minute bits, and then in between we interleave them with exercises so that you make sure a learner from somewhere else that may not have support by themselves have the immediate feedback from the exercise before they keep going to the next section of the lecture. And then this scaffolding also decreases as they get more advanced. So throughout one course, at homework, just like on campus, homework is harder than the lecture exercises, then there's the final exams, so on. This also happens at the program level. I'm going to show you a bit. So here's a snapshot of the probability course. You see at the very top there's a sequence. This is actually one lecture. All the parts that have a video little icon means that that page is a 5-minute or 10-minute clip. And then there'll be exercise like this where the learner will enter their answer in the box and click submit, and they'll get after a few tries, they'll get whether they're correct or not, and also commentary afterwards, the full solution and some remarks, as if you were tutoring a student, once they get something, you might want to share with them some more knowledge. So it's the same idea in the other theory course, in the Fundamentals of Statistics course. In the machine learning course, then after the theory, we also give the students projects. We give them data sets, and they would do projects on their own. But this project comes with these kind of coding exercise. So students will enter their code into the platform, and it will check. It will give them feedback whether they're correct or not. Then at the end, at the data analysis course, we assume that they know the theory, and we assume that they can code somewhat. So at the end, we give them projects which is more open-ended. So they are to submit written reports to us. We cannot grade them by hand, but they are peer-graded, and there's open discussion among the whole, 500 people who are submitting. They comment on each other's openly, and the work of everyone is visible by everyone. Yeah. So at the end of the, program, 1,200 challenging problems our learners would have done. And they would also be interacting with each other on the discussion forum. These courses are instructor-paced with weekly deadlines, and these are supported by our TAs. To make all of this extra content, it takes a village, like the rest said. These are some of the postdocs and graduate students that have worked with us. And notice that we have enlisted the help of 31 TAs since 2017 and 4 postdoc. And they are from all these different departments, ECS, math, of course from IDSS, from econ, from poli-sci, and from CEE. And of course, we need to thank our IDSS team that provide tremendous support. Without them, it would not have happened. Susanna, Jeremy, Aaron, to a lesser extent, but still very important, Erica, Kim, Suzanne. And I think with this, I'll segue just to introduce our next speaker. In 2019, BREIT and IDSS joined forces, and this partnership is, have a large part to do with the MicroMasters program. We provide them with live support. We do recitations and feedback for the NGO challenges. And so far, total there have been 7 cohorts, and the eighth cohort will be joining in May. Okay, thank you so much.
Okay, thanks, Karene, for that introduction, and thanks, Manser, and thanks the IDSS team for inviting us. Also, as Karene mentioned, it's not me just here today, but also Ivo, who is the representative of Aporta, and I'll tell you more in a bit. And also we have 5 of our most talented students from different cohorts. We have Rodrigo, Ulises, Christian, Cynthia, and Diego that are here today with us. And it's exciting for us to have tangible impact around here. So it's not me talking, so they are the demonstration of the impact the program is having. So this is an educational partnership, and what we are doing is we're leveraging the MicroMasters to train the next generation of data scientists in Peru. And just quickly, who we are. BRECA is one of the Peruvian biggest business conglomerates in the country, and it has operations in different sectors like mining company, painting company, fishing company, insurance, real estate, and so on. And it's a group that is very devoted to not only business, but also to the social impact that they create. So they have Aporta, who's the BRECA social impact platform, and BREIT is incubated in Aporta. But we are a philanthropic initiative that is funded by one of BRECA's shareholders, who is Ana Maria Brescia. And Ana Maria Brescia is a 95-year-old woman that in 2018 had this vision that she wanted to fund a higher education initiative that could have a long-lasting impact in the country. And that's where all the conversations started, and there were different initiatives or different options, but data science was something that was already there, that was emerging, but in Peru, still not today, there's still a gap of talented people that could fulfill the demand that the organizations, business, different organizations, and government in general would need now and would need in the future. So it was a very interesting field to put a fund and to start training people to devote to this field. So that's where it all started. And our mission today is that we really want to strengthen the data science ecosystem in the country. And by that, we will contribute to having an impact in the economic development of Peru. How we do that? We train talented professionals in data science so that they can be the next leaders, the next change makers, by using analytical skills and by also making a really positive impact in the society. And that's where IDSS came into play. And we couldn't find like a better match or a better partner to fulfill this endeavor than IDSS, because we really are aligned and we really share the mission. And as IDSS is solving societal problems, complex problems, by using analytics, right? By using different fields. And that really was a perfect match for the purpose that we do have. So just to talk a bit more about the program per se, so it's a 20-month program that we call an integral program, and I'm going to talk a bit more about the different components of the program. And we rely a lot, technically, of course, in the MicroMasters, but it's a blended model, so we have online synchronic and also asynchronic spaces, but also after COVID, we started having some in-person meetups as well. And we do have a rigorous selection process. Everyone that wants to be part of our program needs to go through a technical exam that we've developed together with IDSS. Then they need to go through an English assessment because, of course, the MicroMasters is all in English. Then they go through a personal interview where we really see the fit of the people with the program and see their potential to really become these leaders we want to train. And also we do a socioeconomic evaluation. So just to put that again, is we train leaders and change agents in the field of advanced analytics. And that's why we think it's very important to combine both technical and global skills as well. So these are the three main components of the program, and I talk a bit more about each of them. It's the technical one, the global skills, and we'll also have an integrated challenge in the second year of the program. So first one, the technical skills. We get all the support from the MicroMasters, and students don't only take the course asynchronically online, but they also have, as Karene mentioned, the support of weekly recitations and office hours directly from the TAs from the IDSS. And we also support them additionally with local TAs, which are alumni from the first cohorts of our programs. And they have some spaces, like this was, for example, a hackathon just before starting the machine learning course. And they have all these spaces to complement the online training. Then we have the global skills. And what we think is that if you really want to be a leader and you want to change things and you want to lead people, then you need that other skills. So we have different models in leadership and communication, in personal brand as well, and also we've just included a specific model in ethics for data, because we believe, I mean, it was around the program, but we believe that we wanted to put a special model in this. So that's online and also some in-person spaces, as you can see here. And the third component is what we call the integrative challenge. And the students in this part, they work with nonprofits, they work with real data, and what they do is they apply all the concepts that they learn in the models, in the technical models, they apply it to solve a problem that a nonprofit would need. So the nonprofit shares real data with the students, and then they have this three-phase project that they start with the ideation phase. So they have all these discussions with the NGOs, they learn the data, they analyze the data, and from there they propose what's the scope of the project and what's the solution they're going to work on. After that, they go into development with back and forth with the NGO, and at the end, they go to transference. So they make sure that they transfer this knowledge to the NGO. Throughout these all phases, the IDSS TAs are there to support the students. And we are also always talking with Karene, how can they support better students? Right now, students, we've just developed a rubric, and now they need to show a report as well, do some more presentations. So we are making it this not only a project with the NGOs, but also having all the feedback from the TAs from the MIT and make sure their projects are really rigorous. And just, it's outside of the program, but the organizations that we work with, we're already having an impact in them, because we're kind of like planting a seed in them of the importance of data and all the potential that they can use if they use well their data and they make decisions based on data. And finally, this is kind of like other additional pillars, which is a personal support. So we are really close to the students. The cohorts are around 20 to 25 students each. So we get a very personalized touch with each of them. We know where they are. We track them, how they're doing in their grades, in their assistance. So we are very close to them to make sure that they are making the best of the program, and then they are getting all the support they need to follow this 20-month program, which is not easy. And finally, we're building also this community. So we are growing, and we want all of them that are part of the program to actually become part of this community, to support each other, to network around each other, and to learn from each other as well. And some of the achievements, as I'm mentioning, we're growing, and now we have 7 cohorts with plus 150 people with really high retention rates and really great grades. You can see some of the faces around here, and now we're proud to say that we're the second country with most graduated MicroMaster students in the world after the US. So that's really something that we are proud of, and we want that to continue growing. Also, we can see some improvement in their careers, and we see how the program has had an impact in their professional and personal development. They have gotten better jobs, they have been promoted, they have gotten better salaries, and really they have seen an improvement after passing from the program. But most importantly, I think they are seeing a different phase of data science and the potential that data science has in different social fields. So this is just some presentations that the students did this Wednesday to the IDSS team. And I was really proud of them, and really happy to see how the program has had an impact not only in their 95 jobs, but also in other aspects where they are using like analytics and AI for agriculture, health, and you name different fields that they are making really a positive impact. So I'm really happy to see that this is having an impact outside of their jobs as well. And finally, this couldn't have been possible with all the support from the IDSS team. So I think this has been like a journey of learning, I have to say in one word. We've been learning between each other, and we're constantly learning. I think this never ends, this keeps evolving. And this is just 4 dimensions of knowledge. In the admission process, we've learned a lot at the beginning, but we're constantly learning how we can do it better, how we get the students, how we get the right students in the program, the support that we want to make them, how we build the community, how we continue building the community with the alumni, and finally, how do we use the mentorship in the best way to give them and make them get their full potential. So I think I'm done with time, and with that I'm going to end. And again, thank you for the IDS team to have it here, and thanks all for listening.
All right. Well, thank you. It was amazing to see the impact so far with IDSS and all the other our fellow education partners, and I can completely attest to that. So first of all, thank you to Manzar and Devavrat and the entire IDSS team for inviting me over here and giving me the opportunity to talk about this wonderful partnership that we've been working with them on. What I'll do is I'll try to just maybe break it up into 2 halves. The first half is what we have done, right? What is it that the impact that IDSS and us have jointly made in trying to, what I'd like to call as, at least my vision is that, demystifying data for the next billion learners, right? And I'll get to that in a bit. But the second part is the why. Like, why is it working the way it is? So I'd love to spend some time on that as well. Let me start with 3 vignettes, 3 stories of some of our alumni. We of course got their permission to talk. In fact, we don't have time for it, but they also put together some video testimonials about their experience and what they're doing before and after the program. This is specifically about the data science machine learning, which is one of the 3 programs now that we are working with IDSS on. But real quick, Sarah, what I did was I tried to sample people from all over the world, right? So Sarah is, she started as a junior analyst at Basra Gas Company in Iraq, right? I picked Iraq as a country, it is hard enough for a woman to get a job in a place like Iraq. It's much harder to kind of rise up that corporate ladder. What she did was, use the online teaching, which I'll talk about in a bit, on how it works, to take data science machine learning course. And as halfway through the course, she proposed a potential initiative at her company. Today, she's leading that. She also got promoted to become a financial business advisor, and she's at Shell BGC in Iraq. Bertie is a person in Ghana, and she was a teacher teaching high school kids. And she, after this course, proposed to the education department there to bring STEM initiatives within the school districts there. And today, lo and behold, she's coordinating, she's kind of leading the effort to bring STEM education, and of course, data science is one of the things that she's bringing front and center into high schools in Ghana, right? Monica is somebody who works for the FDA. She has started an initiative within FDA to bring various data science initiatives there, which was something that came at the end of the course that she did, right? But this is just one of many, many examples of thousands and thousands of students across 40 different countries, across some 20 plus industries, across a series of various academic backgrounds, right? And speaking of academic backgrounds, let me walk you through a little bit through the history of how this whole thing evolved. So what happened was, Manza, Professor Caroline Uller, Stephanie, Devavrat, John. So some of the IDSS faculty got together and said, all right, how can we bring this education to the working professional, right? Not just keep it within the walls of the MIT campus. What could we do for them? And that's where, how can we help, say, people who are in data science or who are interested in pursuing data science, what could we teach them, right? And that was the beginning of what we call as the Applied Data Science Program. It started small. It started 2 years back. But what started small with less than, I think the first batch was less than 100 students. most of it wasn't, almost all of it, all the students were in the US, grew and grew and grew. And today, we have cohorts every 2 months, right? So roughly what you see here is, right now, on average, every month, about 300 plus students are joining, enrolling for this program. A lot of this are, word of mouth. A lot of this is, students who go back to the workforce. Some of them, by the way, don't just start initiatives. Some of them have also launched companies in data science, and then, in fact, even hiring some of our alumni into those companies, right? So tremendous impact there. But the story does not end there, right? These were data scientists, right? And this is, by the way, a very intense program. This is where the faculty teach live, over Zoom in a live virtual, live virtual, right? And it's pretty intense. They go deep into the math, the algorithms, it requires heavy amount of programming. But then there were all these, like Devavrat said, it takes a village, right? It definitely takes a village to start a data science initiative at the workplace. There are these IT teams, there are these, software engineering teams, and they too wanted to be part of the action, right? However, they didn't want to get into that level of intensity around data science, but they did want to know how to use this. They didn't know coding, but they did want to know they want to know enough about data science so they can start working with these data scientists to get these initiatives off the ground. So for them, we had a lighter weight program called DSML, right? And this program, it is less intense, definitely the algorithms, in the math. It does involve coding. And this one, every month, again, it started small, but today, every month, we have a cohort for, in this case, every month, about 300, 350 students enroll every month. So easily over a year, about 4,000, maybe even 5,000 students a year. And the story doesn't end there either, right? So they said, all right, let's start a data science initiative, at my company. But, guess what? A data scientist alone can't, get something off the ground. It truly takes a village when you want to do something, in data science, in AI. It requires you to work with the business folks, many of them, marketers and customer success folks, or folks in operations, or folks in manufacturing. Many of them are not coders. They've never written a single line of code, right? They know their stuff really well, but so the question was, can we teach data science without having them to write a single line of code? And the answer, it turns out, thanks to technology today, we live in this world of a lot of proliferation of what we call as no-code tools, low-code, no-code tools. So think of them as your Excel for machine learning, right? You can do decision trees using something like an Excel, drag and drop. So the same faculty, said, all right, let's take what we teach and try to modify it for that audience who have never coded, but using no-code AI tools, right? And that's where this program called No-Code AI, we launched that. I think we are just about the 4th cohort that just got started, but that's been growing exponentially. And maybe intuitively, if you think about it, there are more non-coders in this world than there are coders, right? So I expect that will probably, surpass the success of the other programs. And mind you, all of this is not at the cost of sacrificing on the learning outcomes. If anything, it's enhancing that. What do I mean by that? So, that graph on the left, there are a lot of what you call as MOOCs, right? Massively online platforms. They can scale. They can scale really well, but it comes at a cost of, the quality, the outcomes, right? So, for example, completion rates. Our completion rates are kind of the opposite end of the spectrum. Students, about 2 out of 3 students who complete our program end up also making a kind of a career transition into some data-related initiative within their companies. 30% of them are women. We are trying to push that further. And at least half of those students are from outside of the US, right, across countries in Africa, right, Ghana and Nigeria and Southeast Asia and the Middle East and so on. Sorry, go ahead, Devra. Oh, I'll just quickly. So which gets me to the second half, which is, what's the secret sauce? What's going on here, right? What is different here? And, I like to use an anecdote that Devrat was telling me yesterday. He was telling me about Professor Sanjoy Mitter. right? Many of you may know him. He's a legend when it comes to control theory. So it seems he was giving this lecture, and there was the audience sitting, and after the lecture, people loved the lecture, and somebody commented that, Sanjay, that was an amazing lecture, right? And you are a god. I mean, let's just face it, you are a god, the way you delivered that. But maybe, Sanjay, someday you can come down to earth and teach the rest of us, right? So, but that's actually where the secret sauce is. So the faculty you see here, I feel that what they have done is they've taken what would have been taught to an MIT grad student and taken it down to, I would like to say, down to earth, to the working professional, right? I'll give John's example. John teaches regression, but he starts that with, an example. I think he uses an example of, marketing, where you attribute which channel in marketing, whether it's Google ads or newspaper ads, which one is resulting in better marketing. He starts with an example like that, which everyone can relate to, and then, of course, talks about, well, let me talk about this thing called regression, which happens to help you solve that problem, right? So that's an example of starting with the end in mind, which something that working professionals can relate to, and then, bringing the math into it. But there's one other thing, and I know I'm almost out of time, but I want to talk about, where does great learning come in, right? What's the difference that great learning also helps bring to this larger picture? Because yes, you need amazing faculty, who can, help explain these concepts to working professionals, but there's something more. Like that same lecture on regression that, say, John gives during the week, on the weekends, that's the other half of the magic that happens, which is, what they do is that class of 600 students, they'll break it down into about 10 to 15 students in a mini cohort, all right? And think of it like a Zoom session that you join in if you're one of those students, and there are 10 others of you. And then we'll bring by design somebody from the industry. We call them mentors. So maybe a data scientist working at Walmart Labs, or a machine learning engineer working at JP Morgan. Right? And what they do is they talk about, well, you learned regression, you learned it from some of the best faculty in the world, but now let's talk about how we use it. I'm working at a bank, let me talk about how I use it in the banking industry, right? Or, here's some best practices, here's some approximations that we make when we have to just make some quick decisions. And that's where, it kind of comes a full circle. It helps them understand that aha moment of, all right, these are the concepts, but these are also how it's actually being used in practice in the industry, right? In fact, those sessions also evolve into, well, I'm not in banking, but I work in e-commerce, or I work in insurance, I work in healthcare. How can I use these concepts in my workplace, right? And that's what makes it special. And there's one last secret sauce, which is something. It's funny. It's something that we always knew. It was never a secret. It was something that was always staring at us ever since kindergarten, which is, when you go to school, we get homework. And when you don't do our homework, when you come back the next day, what happens? Your teacher, picks you out of the whole class and says, hey, Milind, where's your homework, right? And that's what, that simple thing, where's your homework, is what makes you put that all-nighter and somehow, work on your homework, right? This is no different. We literally have 500 plus program managers, that's what we call them, sitting in Bangalore, which if you enroll for any of our programs, if you get a homework, they will call you if you don't finish your homework and ask that same question that you've been asked since kindergarten, which is, hey, Milind, where's your homework, right? So I think so to conclude, I would say, what's the secret sauce? Why is it working the way it is? I would say some great faculty, the industry mentor-based teaching, and that one thing that we always knew to be true, which is putting in the effort and doing your homework. So thank you.
All right, good afternoon. By now, I think you should all be convinced that we're talking here about something really great. I mean, no, I'm not saying that as a joke. It's really amazing what has happened. So seeing what Lucia is describing, what's happening in Peru, how did we manage to get the program there and to make such an impact, Milind's operation is much less trivial than you may think, with all that stuff happening in the background, with hundreds and hundreds of people supporting the program in a seamless way. I mean, personally, I have no idea how something like that could be done. It's not my job, but it does look like a miracle. I mean, what Karene has been doing all these years is amazing, because it's not just that she's managing the programs and getting things to work, but also even changing problems, doing interventions on the technical side of the work. I guess it helps to have a math PhD. Okay, that's a usefulness on that. And then Devavrat putting all those things together. It's an amazing job, and all the stuff as well. And of course, the big congratulations go to Munzer, who somehow got all the pieces in place and the right people and made the connection. The connections always kind of looking around for opportunities, and also figuring out, both Munzer and Devavrat, how to navigate the MIT administration, which it's an interesting job. All right, so what I'm going to talk about is basically a little bit of my own pathway through this space and the experiences that I've had. So about 25 years ago, Dimitri Bertsikas and I inherited this undergraduate/graduate probability class, and I've been teaching it on and off about 15, 18 times, I don't know. Roughly 2,000 students have taken it overall. Okay, so it's great, impacting the minds of 2,000 students, discounted for 50% who are asleep during class. You kind of impact about 1,000 students. But we got excited, we took our course notes and wrote a book, and so that book gets adopted elsewhere. In some books are the way that education has been globalized for the last 500 years, right? That's the instrument through which education started scaling up with the first universities and so on. So by a rough estimate, about 25,000 copies may have been sold. I guess quite maybe a comparable number or more have looked through that from pirate copies on the internet. So, okay, it's a decent impact. You kind of feel good that it's used in several places. And then MIT at some point had this wonderful idea how to make MIT materials accessible to the world at large, and it launched the OpenCourseWare project. So we did something very simple with this class. They just recorded the class as it was running live, no extra work, and they took all the documents and the assignments and all that and just posted them. And there it has been pretty amazing. Okay, the first lecture in the class has more than 1 million views, but you can discount that. It's just curious people. But this count of 100K views is from a lecture which is somewhere in the middle about continuous random variables. Does anybody recognize what that problem is? The Buffon's needle. Okay, so quite a few people go through that class and without actually having done much work. And then edX came in, and we decided let's do an edX style class. And here we changed the format completely. Instead of the live videos, use the format of tablets with some PowerPoint, but doing things kind of live by writing on the slide. So that started a little before IDSS, so there were a few runs. That's why the enrolled number sounds inflated. But now enrolled means, okay, I'm curious about quantum mechanics, I enroll, I watch one video and go home. So that number doesn't really count. I think what really matters is how many people actually paid real money and stuck through the course and went through it. And it's actually a pretty serious number if you compare it with, let's say, numbers of MIT graduates and all that. It definitely has scaled up. So it has been part of the IDSS MicroMasters. It's been greatly managed, and we think that it does have quite a bit of impact. So we now have all these formats and platforms out there. Which one is the good one or the best one? It does puzzle me because the tablet videos that I have, I think that they're almost the best I could do. They're really comprehensive, nothing is missing. Whereas in lecture, you kind of hand wave, occasionally you jump stuff. The lectures are not really self-contained. But even so, people do go to YouTube and watch the open course videos, even though the others are also available on YouTube. So why is that? Why do both coexist? Well, the thing is that this landscape is really multidimensional when you start thinking who your audience is. There's the curious people, there's the people who want to get a quick idea, you have the professionals who want to kind of get a bit of practical knowledge, and then there are the serious undergraduates who want to really become researchers and scientists. And out of those audiences, they also have different objectives as well. And some people like intuitive materials, some people like rigorous materials, some people like to also have computational exercises. Interestingly, in my class, there isn't a single computational exercise, and interestingly, no single student has ever complained. But it's a course that's really on fundamentals. So the computational stuff comes in the later courses, in the MicroMasters and in the other programs. And finally, one realizes that people have different learning styles. So if you're trying to ask what's the best way of delivering the material, there isn't one that's best. Different people learn in different ways. So now, let's do some science and show some plots. What does it take to learn a subject like, let's say, undergraduate probability? Here's my plot. Okay. There's a level of mastery, and depending what level you want to get to, you will need to spend different amounts of time. I would say that much of the online material there, which is for the broad masses, the Coursera type of things and many other online courses, are probably in the bottom left corner, where you want to spend just a little bit of time, get a little bit of an idea about the subject. In our program at MIT, we've kind of decided, I don't know, by design or just because that's what comes naturally to us, our niche is up there. We're aiming for mastery of the material. Actually, the online class, at least in Talk for Mine, they are getting better and more material than MIT students get on the residential class, because it's more complete with those little exercises between the clips, every detail has been thought out, whereas at MIT, okay, you get a snow day, vacation, Patriots Day messes up the schedule, we skip a homework, a recitation, things are not that well streamlined, whereas the online class is very good, and we don't make any discounts. They have to do at least as many homework problems as on the residential class, and at the same level. So this is our niche. Now, this plot is supposed to represent a typical representative student, and we have a curve of this kind. What more can we say about that curve? Okay. First, where is that point where you get to the saturation? What do you need to learn a subject like probability, undergraduate probability well? Well, I would say that it's about 200 hours, and there's no escape from that, no matter what medium you use. You learn better from books or from videos or from just chatting with a friend. It will take about 200 hours, and that's sort of in the same spirit as people have saying that to really master something, like to become a concert level pianist or violinist, you need 10,000 hours. You want to become a star in other fields, like 10,000 hours is the quota. Well, probability is just a small piece of your education, so it's about 200. Now, this curve, I guess, is to represent a person with reasonable motivation and kind of reasonable skill, not an Einstein. They don't have to be the top people in the field. I believe that these subjects are accessible to pretty much anyone who is motivated. Can we kind of push that curve? Well, I think that the curve of an ideal person of a typical person for an ideal class is what it is, and it's pretty invariant. What kind of makes a difference is a little bit of the course content. If you have a better course, then you help the learning happen a little better. But I would say that these days there's probably courses that lie along that frontier, that there isn't a big room for improvement. So using favorite language of Munzer are the fundamental limitations here. And my guess is that there are fundamental limitations, that basically this curve is not really shifting. As long as you have the kind of right material and the student is well motivated, that's what it is, and no matter what we try to do with technology, it's not going to be pushed. You will always need 200 hours to get mastery of undergraduate probability. What can make a difference, however, is first mediums that motivate people. It should be pleasant. And the other thing, of course, the huge difference is that with this online education, we're scaling up and we're reaching the entire world. So that's where the real big impact is. Not so much that the content has changed, it's really the global impact that's the important one. Okay, so I talked a little bit of the demand side. Now on the supply side, to develop an online class, there's a similar trade-off curve. Depends how good a job you want to do. And at least my experience was that 1 hour of lectures for those tablet videos took me about 20 hours of work. And that was for a class that I had already taught, but had to rethink how to rearrange the material, what to put on the slides, create the slides, think about every word I would be saying, do the recording, re-record because I don't like, edit a word that I don't like, and so on, and review the videos and transcripts and all that. And now, if you start thinking about adding recitation problems and guiding your TAs and choosing problem sets and all that, it very well run into exorbitant amounts. Okay, now, people can manage with 5 hours per lecture. I guess that's the minimal, just to think through what you're going to be saying. Just look at your slides and go in front of your regular classroom and review the video afterwards. That's, I think, it's really the lower bound. But it's hard to get the right level of fine-tuning for this medium. Hopefully somebody will discover some magic bullets. Of course, human resources and good staff make a difference here. The more you can delegate, the easier it gets. So whatever we can do to move in that direction would be helpful. So takeaway points, things I already mentioned. Okay, one needs to have a particular kind of audience and level in mind. It takes a lot of work to do. Having Karene on the team is maybe the most critical thing in doing something like that. But also a bad observation is that good enough, somewhere in the middle of the curve, may be great, but in this global world where everybody compares globally, one needs to get to that peak. So good enough is not necessarily good enough. It's a winner-take-all industry. I'm happy to be doing this for probability, where the material has been settled for the last 50 or 70 years. If you're doing a class on deep neural networks, where unfortunately you have to do a lot of work every year. But it's definitely, to summarize, a lot of work, but it's absolutely rewarding to be doing this in many ways. It's finally you feel that you have some impact that goes beyond the 30 students sitting in front of you in a classroom at MIT.
To do panel discussion. First of all, there was all amazing talks, lots of learning across not just a multiple dimension, but multiple dimension. And as I can see, that there are questions that are getting ready. So instead of asking my question, which may not be the best one, I think I would like to invite audience to start by asking questions.
Hi, I'm Fernando Paganini from Uruguay. I guess I have a general question regarding this online learning world. I mean, for us who live in South America, and we also teach a probability class, and of course, having an online MIT open course where there is, like, to some extent, competition. So I was wondering if you had given any thought to ways to articulate what you do with, I guess, the global academic world.
Well, I guess the philosophical question is, given that there is this MIT class, why teach your class? It's a, yes. So places did,
I do have an answer for that, but I just wanted to get your take.
yeah. No, I did play with that idea at the Greek university where I was involved in for some time, and basically people were not interested, and I can see why. One is, first, you want to feel that you're doing something. You have the personal connection with your students, which adds very much on the motivation side. I believe that some people have experimented with hybrid formats where they tell the students, watch those videos and then let's come to class to do something. But I have a feeling that this hasn't really exploded. So I think it remains to other universities to figure out ways of doing it.
I'll just add one thing here that, like to John's point, the hybrid model. So we have been doing that where, so you're right, John's lecture on probability, they will watch it, but especially for, since you mentioned you're from Uruguay, we also have translated that into subtitles, Spanish and Portuguese, which kind of helps. But those live sessions, those mentors, those are from Brazil or from Mexico, right? And then they explain, they explain in English, but it's kind of like Portuguese English. They'll bring in the Portuguese words because they help explain that same concept in their local context. And context matters is what I think, especially when you're trying to explain it to working professionals. Anyway, that's been my experience.
Okay, I also want to mention that, there is a point to have giving access to everyone who wants to access these material as a way to accelerate their master's degree. So even in Uruguay, there's the Master's in Data Science program at the UTAC, one of our strategic partner, right? So then the students who didn't get access beforehand can now access this and accelerate their master's degree as well.
Wonderful program. I have two questions, and they are kind of serious. The one is, we all talk about hands-on experiences, and that the whole education system is moving to hands-on experiences, and without it, we don't really have any guarantees that anybody learns stuff. Hands-on experience. And the other question, it goes back to Vannevar Bush, who did a lot of things here, okay? And it has to do with his, I don't know if you know it, he will make lectures according to cards. And the cards were causally related so that you could actually take the same course and design it with take it with different paths. Now, what has happened in the physics education of the fundamental courses, under the leadership of a faculty that is a colleague of mine, and I talked with him for 20 years about these things, Ed Redis is the name, they took that in all the fundamental 6 courses of physics and they computerized it. Meaning when now you have something like a hypertext, a navigator, that if you are a student, and depending on your background, it guides you how you can walk through the course. Why is that important? Is because it allows both teachers and students to go through the course based on their background with perhaps shortest paths, longest path, or whatever. And when he showed me that, it blew me off, okay? I mean, really. And I've been trying, I'll tell you my scene, okay? I've been trying to get our control colleagues to do something like that. I don't get any traction. So here are the questions. How do you give hands-on experience here, if you believe that's a good idea? And second, have you run into this kind of ideas and tried to create this kind of navigators for these courses to help both the instructors and the students to go through a particular, let's take John's course, which I know inside out, but I can give you different paths for this course depending on the student. For instance, if you are in operations research or if you are in communications engineering and so on and so forth, you may have different paths. By the way, I like the program very much. It's fantastic. The scale and everything else, I can never imagine anybody can do anything like that. But I don't know, the question still stands. Maybe it's an improvement, I don't know how you would call it. These questions have been bothering me for years. Yeah, please.
I can speak a bit about the hands-on experience, and I think as I explained the program, that we run, the students do have this hands-on experience with these social projects, with real data. And I think that's, as you mentioned, it's really important to put all the knowledge and all the theory to the practice. And I think that's critical to really not just talk about the theory, but really understand the problems that arise when you actually are working around it with real data and with real world problems. So I think that's critical, and that can be work around in different ways depending on the scale. If it's smaller scale, maybe it's easier. That's coming, yeah, we do have the mentors that are alumni from our programs, for example. They do work in the industries, and they help the students in their projects with the nonprofits.
No, I guess I'll just add that the second question about different paths. So, okay, like a course navigator path. Personalized learning. Okay. Right. Hmm. Hmm. Yes. No, I guess that's a personalized education is kind of a little bit harder problem to solve, right? You know, everybody has their own, whatever they do at work is very unique, right? And to say, I'll customize this course completely to, you're a marketer in an oil and gas company working on the following project right now, and what's the course for me? You know, it'll be hard to, it'll be a million paths. Yes, yes. So I think I can just say the approach that we have used is the faculty have been sticking to the fundamentals, right, and using examples from the industry. What we do have, though, is like in that applied data science program we saw there, they are required to do a project at the end of it, a capstone project. And there we encourage them to think of a project from work. So back to that marketer in oil and gas company, you know, might say, hey, look, I learned that regression and I learned that decision trees, and here's the project. I'm thinking, can I use it here? And that's where we guide them. So that's that personal touch. I guess it's a hybrid. We can't make it super personalized, but maybe that project can be personalized. At least that's what we've done.
So you've got two choices. Sus has given me 1 minute one. So we got two options. Option one is to take one more question, which I think we have already ready, and then spend 1 minute on that, and then sort of continue conversation on this question afterwards, if that's okay. Please.
Yeah, I think the question is great, so that's fine. I was just wondering, given that, you know, we are several in Munster's group, Taylor, Bernardo included, interested in, you know, using causal inference for education, and I think it's related to the question of personalized learning. I know these data are probably private about the student outcomes and so on, but is there any plan to now, you know, leverage that experience of running a program at scale worldwide to, you know, have, let's say, a doctoral student actually focus on, you know, causal inference for education and reinforcement learning for education, learning how you move like one student from one state to another, let's say, or like these ideal trajectories that we were talking about, like ideal size, let's say, of a recitation session. Like,
if I may just to sort of paraphrase, is there an opportunity from each one of you to sort of provide access to some of the data so that sort of bright graduate students here can sort of figure out a way to sort of develop methods, such as to answer John's question? And I know, Karene, I know something you've been sort of thinking about. Maybe I would like to ask you to sort of take that question.
Thank you.
We can go through that in that order.
So definitely, yes, we can offer, well, okay, with a lot of processes, we have lots of data that, you know, if you propose to us that we're happy, we're open-minded and want to do research to improve, you know, to ask any questions. Regarding the navigation among the content, we actually have been thinking about it with the support with Devavrat and Munster. We applied for a grant to develop an adaptive platform geared with sort of with continuous feedback from the learners, exactly so that it would navigate among the content, say, in the micromasters first, to answer an application question. So it would be a research problem. We just written a grant, but we don't know yet.
So sort of a nice opportunity for advertise Karene that if you're interested, don't forget to contact her. Maybe one more comment at least, and then so we can, then so Suze would otherwise sort of come here.
So the question was, getting access to data to work on projects, right?
Maybe John, you're
For education data and outcomes. Well, one is we do, in fact, we also partner with IDSS on various hackathons and datathons, and there are, public databases for education and educational outcomes, so we could absolutely explore holding those. And yes, we also, separately, we also have, if somebody wants to do a project, we can define that, and we can also coach you on it. And this can be a project around education data and how to think about education outcomes.
Maybe if I may ask from a student's perspective, we can sort of send you an email so that we can get access and then sort of start doing something interesting in collaboration as a research, right?
Yeah, I think it would be great, and we'd encourage that. We'd want that, and the idea is, here's what our students can do, and you too, you can too, right? So we'd love to have you guys come and get, work on projects and put it out there for the world to see. Just encourage more people to take these courses.
Maybe on this high note, and given that otherwise I'll be in trouble, let's thank all our panelists for an amazing panel.